Martin says you accept the null. That is true. You have to accept the null hypothesis. Okay. But now look at this. This figure shows when you can make some error called hypothesis error. The hypothesis error, there are of two types, type 1 error and type 2 error. But let's see. Where you were supposed to, so here, by the side here, what do I call this? Do I call this column? Yeah. So by this side, I hope you can see my arrow, my cursor. By this side of the screen, by the left corner of the screen, is the true state of nature. That is when they have the true thing, okay, the real thing that happened. And then this conclusion is your own conclusion about it, your own conclusion. So this part up here is your own, is the decision you took. But this part beside here is what you should actually have taken, like the true position of things. Now we said, I gave an example that if your significant value was 0.38, and of course it's bigger than your error margin, and you were supposed to accept, ideally, or the true state of nature is accept the hypothesis. That is what you should do. Then your conclusion actually accepted, in your conclusion you wrote that you accept the hypothesis. You can see when the null hypothesis is true, that is when the null hypothesis is actually to be accepted. And then you actually accepted it. You have arrived at the right conclusion. But when the null hypothesis was supposed to be accepted because the significant value is bigger than the error margin, but in your reports, you went to reject, I mean, look at your result shows that the significant value is bigger. So ideally, you should have accepted the null. But in your reports, you reported that you rejected the null. You have committed what is called type 1 error. So type 1 error is when you reject a true null hypothesis. So how about if you were supposed to reject the null hypothesis, okay? So let's say your error margin, your significant value was 0.002 and your error margin is 0.05. So your error margin here is bigger than your significant value. That is, your significant value is smaller than your error margin. Ideally, you're supposed to reject the null hypothesis. That is, the null hypothesis is false. You're supposed to throw it away and accept the alternative. So if you rejected, now let's look at this. This is the null hypothesis. If you rejected the null hypothesis when it was supposed to be rejected, you have arrived at the right conclusion. But if you accepted a null hypothesis when you were actually supposed to reject it, you have committed type 2 error. So we hope that this diagram explains it well, because it can really be confusing. So the significant value was lower than the error margin in that report that we saw. The significant value was 0.000, and the error margin is 5%, which is 0.05. Please, which of these two decisions does it fall in? Great. I can see that Priscilla has followed. She says, reject the null hypothesis. You are very correct. So let's see if that is what that researcher did. Did the researcher reject the null hypothesis? Let's see. All right, great. So let's look at this report right now. The candidate then said, although this is not a very strong relationship, it is statistically significant. From the result, it is appropriate to reject the null hypothesis. Yay, can you see you got it right? You rejected the null hypothesis. Why? Because the significant value was lower than the error margin. So because of that, he rejected the null hypothesis and accepted the word alternative. So if the null hypothesis said that monetary factor does not have a significant relationship, And now we are rejecting the statement. Can you tell me what the decision is now? What will your alternative? You're rejecting the statement. Can someone type in the chat what, or can someone say what the alternative will be? If we are rejecting this because our significant value is lower than the error margin, if we are rejecting this null hypothesis, look at what the null hypothesis says. It says monetary factor does not have a significant relationship with the performance. What would the decision we want to take now be? If we are rejecting this, what are we accepting? If we are rejecting this, what are we accepting? Can someone say something? Great. Great. Priscilla says something in chat. So she now says, we are now concluding that monetary factors have a significant relationship. You're very correct. So is that what the researcher said at the end of the day? Let's see. From the result, it is appropriate to reject the null hypothesis and accept the alternative, which states that monetary factor has a significant relationship with. Fine. So can you say you understood that now? Or is it still strange?
The illustration makes it better. Not like I've really gotten everything, but it makes it real rather. Let me use
Yeah,
the word real.
exactly. That's fine. So I'm happy to hear that. So Mustafa, do you get the concept right now? I'm not expecting that you would understand everything, but like, is this kind of clearer right now to you?
Yeah, somehow. But I mean, like later on, I have to just to rewatch it again, or just go to other sources. But yeah, somehow
Okay.
it's clear.
All right, that's fine. So we are now in the case of when do we use what tool? When should you know whether you're using correlation? When should you use chi-square? When should you use t-test? When should you use ANOVA? Sometimes these things just happen and you pick up a work. Has it happened to you before? You pick up a work, the topic is the same, or you see two jobs that the topic is very similar, but the technique they use, this one may have used regression, this one may have used correlation, and then you're like, why did they use what? So that is what we want to know. So choosing the appropriate technique may be quite challenging. And if you make a wrong choice of technique, you may have wrong answers. Or you may do a wrong analysis, which will give you wrong results, and your conclusions will be wrong. And then if you want to use that conclusion to make some decisions in a business, or in a particular environment, or in a particular clinical trial, then you may just be doing it all wrong because the technique was wrong from the start. So how should we know when we should use a particular technique? What should determine our choice of technique? Um, let's just focus on, there are actually three: the objective of the study, the unit of analysis, and the level of measurement. But these two may just be a bit confusing for you right now. So let's just focus on the objective of the study. If your objective is to examine relationship, you just want to examine relationship, purely relationship. Is this related to this? Or is this associated with this? If that is just your goal, then just go for correlation or chi-square. If your goal is just to examine relationship, it's simply correlation or chi-square. If your goal, or if the study you're undertaking is to compare the mean difference, or to compare difference, or to compare between groups, you want to see whether female perform better than male, or whether a particular kind of rats eats better than this other type of rats, all this kind of stuff, then your choice of technique would be the t-test or the ANOVA. Now, the t-test is used when you just have two groups that you're measuring against, male or female. And then you want to see the difference between the two groups for a particular thing. Let's say maybe response to COVID treatment or something. You want to see whether male respond better or faster than female. So you're not seeing you are not examining the relationship between male and female, or the relationship between the male and response to COVID. You're seeing you want to see the difference between male response to COVID treatment and female response to COVID treatment, the difference. Then, since there are just two groups here, it is the t-test. If there are more than two groups, it is what? ANOVA. That is when you want to see the difference among, when it's more than two, you don't use the word between again. You want to see the difference among, then it is analysis of variance, ANOVA. So, okay, I have an example here. I said there's an example of a pre and post intervention. So you have something like some kind of, you want to see the effectiveness of some developmental aid, in a conflict region, like some kind of intervention. The before that intervention was brought into the conflict zone, what was the living standard like in that conflict zone before the intervention? That is the pre-test. So you get the report or the statistical result of the pre. Then after you have now introduced the intervention, you now want to see what the living standard is like after the intervention. So you have a pre and a post test. You use a t-test analysis for that. But if you want to see the difference among several interventions, you use analysis of variance. So you can say ANOVA is a bigger t-test. If your interest is to examine the impact or the effect of a particular variable on a dependent variable. So let's say you want your work reads to examine the effect of, say, so thing on something else. That is X on Y. X being your independent variable and Y the dependent variable. So I think from the beginning of this class, I used the aviation and employment intention as an example. If you want to see the effect of airport safety on employment intention, the key word here is effect or impact. Then the regression analysis is your choice of technique. Regression analysis is your choice of technique. There are several others, as you're going to see. There are a whole lot of them. So these are not the only ones. These are just basic ones, because within correlation, there are different types of correlation. And then there are several assumptions that are guiding them. So like, say, when it's a parametric kind of relationship, or when it's this, use this type of correlation, or use that type. When you want to rank, use this type of correlation. So, but the point is, if it's relationship, know that it's correlation. If it's difference between two or more groups, know that it is t-test or ANOVA. When it is impact or effect of one thing on another, then it is a regression analysis. So you just go check your research questions that you have formed for your study. Did you use the word relationship? Did you use the word difference? Did you use the word effect? You should know which of the two your work is likely to adopt. Yeah, so modeling, okay, or such model, visual models or conceptual models help your reader to simply just visualize what you want to study. They may not necessarily, like for instance, I may not necessarily need to go see your objective of the study before I know what you want to investigate. If I see your model, I can quickly just tell you what you want to investigate. So it is always good that you express your model accurately. So let's go back to some of those things we talked about already.